Okay, this video accompanies the 6-4 student companion notes, and let's get started on this. Our section, we're mainly going to focus on ways of proving parallelograms congruent, which means that, like, if we can show that consecutive pairs of angles are supplementary, well, both consecutive pairs of angles are supplementary, then that would be enough to have opposite angles congruent, which means we have a parallelogram. If both pairs of opposite sides are parallel, we have a parallelogram. If one pair of opposite sides is both congruent and parallel, we have a parallelogram. If diagonals bisect, we have a parallelogram. I think that takes care of all of them. So opposite angles congruent, opposite sides congruent, both pairs of opposite sides congruent, one set of opposite sides congruent and parallel, diagonals bisecting each other, and those are all ways we have of knowing that we have a parallelogram. So let's look at this first one. So they want us to draw a quadrilateral with 0 pairs of parallel sides. No parallel sides, but 2 consecutive sides that are congruent. So I'm going to draw this and label these 2 as my 2 congruent sides, 2 consecutive pairs. So consecutive pair basically forces us into having to draw this kite shape. Okay, for quadrilateral 2, we want to draw 1 pair of parallel sides, and there's exactly 1 non-parallel pair, exactly 1 non-parallel pair of congruent sides. So we draw 2 parallel sides. So these is parallel. And we want 1 non-parallel pair. So let's do this one. And they need to be congruent though, right? Exactly 1 non-parallel pair of congruent sides. So I want to maybe draw a length like this, and maybe the same length over this other way. So there's the 2 congruent sides that are non-parallel, and here we have the set of parallel sides. So this is what we call a trapezoid. Exactly 1 pair of parallel sides. This is actually an isosceles trapezoid because of the 2 congruent sides. This we call a kite. Number 3, 2 pairs of parallel sides and 2 opposite pairs of congruent sides. So this is our normal thing that we'd think of if we think about a parallelogram shape. You've got the 2 sets of parallel sides, and then these opposite sides are congruent to each other. So it's figure 3. Okay, measure the angles of each quadrilateral. How the angle measures in one related to each other. Okay, I don't have a protractor right now to use for measuring, but we will see that those non-vertex angles are congruent. Non-vertex angles congruent, and because it's a quadrilateral, they're all going to sum up to 360 degrees. So that's all we can get on that one. Let's look at number 2. How are they related to each other? Well, we have these parallel lines with this transversal being one of the sides. Got the same thing going on over here, like this. So these angles are going to be same side interior angles with parallel lines cut by a transversal. These are going to be supplementary. So same side interior angles are going to be supplementary there. These 2 angles over here are also going to be supplementary. And then the other thing that we will notice if we were to measure this is that these two angles actually are congruent to each other, and these two angles down here actually are congruent to each other. So in an isosceles trapezoid, we have what we call congruent base angles. Congruent base angles. Now the base angles don't just have to be at the bottom, they can also be at the top. So both of these are said to be base angles. And also pairs of side angles, I'll just call them side angles, are supplementary, which means they add to 180 degrees. So in an isosceles trapezoid, these angles on the top are going to be congruent to each other. These angles on the bottom are going to be congruent to each other because it's isosceles. And because it's a trapezoid with the parallel lines, these two consecutive side angles are going to be supplementary because of same side interior. And these two angles are also going to be supplementary. So if you know one angle, basically you know them all. Like if you know this angle, you know what this angle is, subtract from 180, you got this angle. If you know this angle, you know what this angle is, subtract from 180, you have both of these others. Now in a regular parallelogram, not a special one, we have opposite angles are going to be congruent, and consecutive angle pairs, like this one and this one, 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 are going to be supplementary. So consecutive angles supplementary, and that's because of parallel lines cut by a transversal. You got same side interior angles supplementary. Going the other way, same idea, same side interior angles. Going this way, same side interior angles. Going this way, same side interior angles. So consecutive angles are supplementary. And opposite angles congruent. So that's what we can get about measuring the angles and how they're related in these different quadrilaterals. Let's look to number B, or to B, measure the diagonals in each quadrilateral, how the diagonals relate to each other. So let's see what we got with that. So I'm going to use, use yellow. So if I draw the diagonals for number 1, we have this, and it turns out that the diagonals in a kite are going to be perpendicular to each other, and the major diagonal, which is the longer one, is going to bisect the minor diagonal. So this one's major, and this one's minor. Well, this one's major, and this one's minor. M-I-N-O-R, minor diagonal. So in the kite, the major diagonal bisects the minor diagonal. And also they are perpendicular. So we could say that the major diagonal is the perpendicular bisector of the minor diagonal. So major diagonal, perpendicular bisector of the minor diagonal. What else? The major diagonal bisects the vertex angles. These are the vertex angles. This is a vertex angle. And so the major diagonal bisects the minor diagonal and also bisects the vertex angles. Also bisects vertex angles. So if you know what, say, this half of this vertex angle is, you know what the other half is. If you know what one of the non-vertex angles are, you know what the other non-vertex angle has to be. And altogether, all the angles have to add up to 360 inside the kite because it's a quadrilateral. Okay, let's look at the isosceles trapezoid. In an isosceles trapezoid, the diagonals are congruent to each other. Diagonals are congruent. They don't bisect, but they are the same length. And that's really, I think, all that we can get with the diagonals in a isosceles trapezoid. So to kite, isosceles trapezoid, that was number 2. This is number 1. The parallelogram now, draw the diagonals here. These diagonals in the parallelogram are going to be angle bisectors. So in the parallelogram, the diagonals bisect each other and also the diagonals are angle bisectors. Now they're not congruent, but they do bisect each other. That means each, if you know what one half is, automatically you double it. You know what the total is. You move the one half to the other side, and you got like what the other piece is. Same thing going the other way. Okay, let's go on. Compare the relationships between the angles and diagonals of quad 3 to the other two quad. Are there any relationships that make quadrilateral 3 unique? Well, both diagonals bisect each other. In the kite, only one. The diagonals are angle bisectors. In the kite, only one set of angles is bisected. In the parallelogram, they're not congruent. In isosceles trapezoid, they are. So relationships that make quad 3 unique, the diagonals bisect each other. So I'll just kind of mark it up here maybe. One thing is the diagonals bisect each other. Unique, diagonals are angle bisectors. Both diagonals are angle bisectors. And diagonals are congruent. Or no, diagonals are not congruent in number 3. And that's pretty much it, I think. That's what makes it unique. Diagonals are angle bisectors, and the diagonals bisect each other. Okay, let's move on. So look at example 1 here. So explain why you cannot conclude that ABCD is a parallelogram. So we have, by side, 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 we have that these two triangles are congruent. So by corresponding parts, we could say that those are congruent to each other. Those opposite angles are congruent. By corresponding angles, we could say that those two angles are congruent to each other. And also, by corresponding angles, we could say that those two angles are congruent to each other. Now, could we actually do that by corresponding angles? So with this diagonal, we could conclude, since we have alternate interior angles congruent, so because these two triangles are congruent by side, 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 we have that this angle DAC is congruent angle BCA because of corresponding parts of congruent triangles being congruent. Now that's enough with alternate interior angles to say that this side and this side, but I kind of messed up on that. Let's go back. I just saw how these were marked. So it's going to change our angle relationships here. Let's go back and start over on this. So forget what I just said on that. So the way this is set up, let's mark the congruent parts. So we got those parts congruent, we got those parts congruent, we got these parts congruent. So we could say triangle ACD is congruent to triangle. If we're going ACD, we have to go ACB. We get that. Now the two triangles are going to be congruent by side, side, side. So we do have that. But in terms of their corresponding parts, this BCA angle is going to be congruent to DCA. So BCA is congruent to DCA. And that's by corresponding parts of congruent triangles are congruent. So notice these are different. BCA is this angle here. DCA is this angle here. So these are matching angles between these two triangles. And then these two angles here give us that. So that isn't enough for us to do anything with opposite sides being parallel, because these angles are not congruent. So we can't say that these two sides are parallel. And since these two alternate interior angles are not congruent, these two sides here cannot be parallel. So basically, because angle BCA is not congruent to angle DCA, we can't say opposite sides are parallel. So we can't have a parallelogram. And same thing goes with the other angles here. These two angles here also aren't congruent. Alternate interior angles not congruent. So BC is not congruent to AD, or not parallel to AD. And because going this way, BAC is not congruent to angle ACD, we can't say that AB and CD are parallel either. So we can't have parallel sides. Let's look at number 2. Is it a parallelogram? Explain. Now, if it's a parallelogram, opposite angles are going to be congruent, and same side interior angles are going to be supplementary. So we're just dealing with the angles on this one. So this is a supplementary angle pair. If it is a parallelogram, these are going to add to 180, which means that would be a 27. And 27 and 27 are opposite angles congruent. That one is a parallelogram because opposite angles are congruent. So yes, it is, because opposite angles are congruent. Let's look at part B here. Is LMNO a parallelogram? We don't have opposite pairs of angles congruent. So no, because opposite angles are not congruent. Okay, let's move on. We want to make these into parallelograms. So we want to find the x that makes these angles equal. We want to find the y that makes these angles equal. So when we do that, we have to set these two equal to each other and solve. And we can set y's with y's and x's with x's, so we don't have to do anything special. So x plus 5 equals 2x minus 10. Take 5 away from both sides. X equals 2x minus 15. Take 2x away from both sides, minus x equals minus 15. X equals 15. So now if x is 15, I kind of didn't see this part here. If x is 15, these are going to be parallelograms. Well, these opposite sides would be, or opposite angles would be congruent. So it takes 15 to make it a parallelogram. Let me try the same thing with the y's, and then we'll look at what they're giving us. So we could say 5y minus 10 has to equal 3y plus 50. If it's a parallelogram, those angles have to be congruent. Add 10 to both sides. 5y's is equal to 3y plus 60. Take 3y away from both sides. 2y's is equal to 60. Y equals 30. So y equals 30 is going to give 90, 140 for this angle, and 150 to 140 for this angle. So that's going to give us congruent angles. But now if x is 25, that's going to give us 30 for this angle, and it's going to give us 40 for this angle. So with what they give us, no, it's not. Because angle P is not congruent to angle R. If we use, if x equals 25. Yeah, I kind of saw it the other way. I saw that for it to be a parallelogram, x would have to be 15. But with x being 25, those angles are messed up. The other angles are congruent. Okay, let's look at part B now. Okay, here, now, if we have a parallelogram, another property of parallelograms is that opposite sides are going to be congruent. So if I put h into here and here and get the same number, we have one pair of opposite congruent sides, and then we would have to do the same thing and see that G also gives us the same number. So let's see what we get. We put 5 in for H, that gives us a 6 for BC. We put 5 in here, we get a 7 for AD. So right away, no, not a parallelogram. Because BC is not, segment BC is not congruent to segment AD. We don't even have to try the other ones. Now, if you did do the other ones, you would get 28 minus 11, you get 17, and you get 17. So it would work this way, but not this way. But one instance of both pairs not being congruent with opposite sides, you can't have a parallelogram. Let's move on. Example 4, investigate diagonals. Now, in parallelograms, diagonals are going to bisect each other. And I think I told you wrong before. If we go back up here to the first, the diagonals of a parallelogram are not angle bisectors. So diagonals are not angle bisectors. That's only if you have a more special parallelogram, like a rectangle or a square or a rhombus. So I messed up on that. So in a parallelogram, only the diagonals bisect each other. Okay, so for this one, back to example 4, if this is a parallelogram, then these diagonals are going to bisect each other, and that's going to be the midpoint. So we've got Q's in both parts there. I can set these equal to each other to make both these parts equal. So 3Q plus 1 equals 2Q plus 3. And find the Q that makes it work. Take 2 Q's away from both sides. Q plus 1 is equal to 3. Take 1 away from both sides. Q is equal to 2. So if Q is equal to 2, we have 7 and 7. So we've made those congruent to each other. That means that this BD diagonal bisects the AC diagonal. Now, for it to be a parallelogram, they both have to bisect each other. So B to the midpoint would also have to be the same as M to D. So if we set 7p plus 1 equal to 5p plus 3, we can find the p that would make that work out. Take 5p away from both sides, 2p plus 1 equals 3. Take 1 away from both sides, 2p's equals 2. Divide by 2, p equals 1. So if p's equal 1, if p equals 1, these would be congruent. That's going to give us 8 for this one. That's going to give us 8 for this one. So p being equal to 1 and q being equal to 2 would force this to have to be a parallelogram because diagonals are bisectors. Bisect each other. Let's look at number 5, example 5. Is this a parallelogram? Okay, let's see what we got. So we got one set of opposite angles congruent, but we don't have both sets of opposite angles congruent. These angles aren't, we don't have anything else going on to give us any information, so there's not enough information. We would have to have the other angles congruent, or we would have to have something about a diagonal in here for us to maybe be able to do like alternate interior angles or something like that. So there's not enough info to say, so we can't say that it is. Let's look at B here. So here we have so these sides are parallel, these sides are congruent, and we have a pair of these same side interior angles that add up to 180 degrees. So angle F and angle E are supplementary. And also we have that FG is congruent to EH, the way the diagram's marked. So here we have with 151 and 29 being same side interior angles are supplementary, we can say that FG and EH are parallel to each other. And also from the diagram, we have that they're congruent to each other. So here we have a case where we have one pair of sides, both congruent and parallel. So it's a parallelogram. So if one pair of sides are both congruent and parallel, it's a parallelogram. Otherwise, it's going to take both sets of opposite sides being congruent or both sets of opposite sides being parallel. And this can be proved pretty easily if you were to try to prove it. Let's look at example 6. Carpenter builds this table shown. So what he's done is they're showing us that the diagonals bisect each other. So if the diagonals bisect each other, the table is a parallelogram. Because diagonals bisect each other. So that means that since it's a parallelogram, these opposite sides are going to be parallel to each other, which means that a ball placed there should not roll off. So ball will not roll. Ball should not roll if it's a fair ball. LOL. That's our conclusion. The ball should not roll. Okay, let's move on. So, essential question. Which properties determine whether a quadrilateral is a parallelogram? Okay, sides, parallel, incongruent, and or congruent, depending on the combination. Angles, opposite angles, being congruent. That's enough for it to be a parallel